Boys, today we're looking at extending the formal multiplication algorithm, but we're looking at multiplying two-digit numbers together using the algorithm. The rules are basically the same, but there's just one minor change that happens when you start multiplying two-digit numbers. So I want to come up with a problem. I want to show you how to do it. If you've done it before, it's really, really easy for you. Just please make sure that you're not rushing through and not making any simple mistakes. If it takes you a little bit longer to get it, don't be upset, don't be afraid. It does take a little bit of practice to get the structure right. It is a little bit different. Feels a little bit uncomfortable to do if you're not really sure as well. But if you just remember that your simple times tables matter, place value is very important, and you need to do some adding as well. If you get those three little simple steps right, you'll be okay. So I want to look at a problem. Let's say I wanted to buy a fidget spinner in 5 Blue. I definitely don't want to, but let's treat it as a maths problem, hey? Let's say I wanted to get you a really fancy fidget spinner that costs 20 bucks. So if I was setting it out as a multiplication problem, it'd be $20 multiplied by the 26 students in 5 Blue. The very first thing I need to do is just write out my problem. So I need to write it in the algorithm. So it's going to be 20 multiplied by 26. And just like using the formal algorithm for 3 or 4 digit by 1 digit, we always start with the ones down here. We always start with this number here. I'm just going to change color briefly. And we start by doing 6 ones multiplied by 0 ones is 0 ones. Then we multiply across. 6 ones multiplied by 2 tens is 12 tens. And I've lined that place value up very neatly. Here's the only difference. When I move on next, I've multiplied all my 1s, so I'm done with the 6 here, and I'm moving over to look at the 2. This number here is 2 tens. So just before I even start multiplying, I go and write a 0 down here in the 1s column, because I know that any answer I come up with here is in the tens column, because this number is 2 tens. And I multiply across. 2 tens multiplied by 0 is 0 tens. 2 tens multiplied by 2 tens is 4 hundreds. And I can just put it straight down there because I've already put my 0 in the tens place. The next step is to simply add the 2 together. 0 and 0 is 0, 2 and 0 is 2, and 4 and 1 is 5. 20 times 26 is 520. So if I wanted to buy a fidget spinner for everybody in 5 Blue, I'd be looking at paying $520. No thank you. I just want you to keep practicing these ones. So, just make up any numbers in your stepping stones book on a scrap of paper in your grid book. Just practice it. Have a calculator next to you to check the answer. Check your answer using the partial product strategy. Just do whatever you like. Remember, when we multiply two-digit numbers, let's do a nice easy one like 13 times 12. 3 times 2 is 6. 2 times 110 is 2 tens. Because I'm done multiplying my 1s, and now I'm moving on to my 10s, I put a 0 down before I do anything else. 110 times 3 is 3 tens. 110 times 110 is 100, because 10 times 10 is 100. Add them together, and I find myself with 156. The most important step in that formal multiplication algorithm for two-digit numbers is putting a 0 down in the 1s column when you're finished multiplying your 1s and you move on to the 10s. If you leave that out, it's the biggest mistake that you can make. I hope that makes sense to everybody. As you're working through and doing your revision for the test that's coming up in week 8, I just want you to make sure you're solid with your multiplication, and that's everything we've done so far. The formal algorithm that we can see here, the partial product strategy, and even going back to look at things like your factors and your multiples. If you're good at all those things, you'll be right for the test. You'll be right for all the work we're doing in class as well. If you jump over to My Maths Online as well, I've put a few activities up there. Good luck, gentlemen.